If you've been using a MacBook for a few years, you've probably noticed that some of them can get really hot. It's not just you and it's not just your laptop. MacBooks overheating and thermal throttling has been a common issue for years now. More specifically, it's been a major issue ever since Apple redesigned both the 13 and 15-inch MacBook Pro models back in 2016. This also includes the new M1 MacBooks, as they still use the same chassis as the 2016 models, although unlike their Intel counterparts, the M1 chips are much more thermally efficient and therefore produce less heat and are less prone to thermal throttling, although it still does happen to some extent. More on that later. When you consider this wasn't too much of an issue before the MacBook chassis overhaul in 2016, even though earlier laptops did get warm as well, what happened during that redesign that led to these thermal issues? Why did MacBooks overheating become such a big problem? First, a quick message from our sponsor, Parallels. Parallels allows you to use Windows on your Mac, so if you want to play Windows games or perhaps you have a specific app that only works in Windows, Parallels allows you to use that on your Mac without having to restart it. Check out the link in the description for more information. Now, the first issue with MacBooks overheating is the physical size. Even though they're often quite good for demanding workloads, Apple designed the MacBook to be an incredibly light and slim, ultra-portable laptop. So to achieve this, they needed a CNC machined aluminium body, which at that thickness doesn't leave a lot of room for components inside. Yes, it looks and feels incredibly nice, perhaps better than any Windows laptop out there at the moment, but it does lead to some issues. Even the Dell XPS lineup, arguably the MacBook's biggest competitor, is a bit thicker and features more venting options. More on that later. Inside the MacBook is not just the motherboard and components attached to it, it's also the cooling system. When Apple wanted to make everything as compact as possible, the cooling system took a bit of a hit, which is why MacBook Pros, for example, have some of the smallest, slimmest fans you'll find in a laptop. This size constraint means they're limited in terms of how much air they can move, and consequently how cool they can keep your MacBook. The other big thing that happened during the redesign was the removal of almost all visible cooling vents on the MacBook. When you're trying to cool a computer, ideally you have one vent where cool air can come in from and another one where the hot air can exit or exhaust from. With a powerful enough fan, which the MacBooks do have, you can push the hot air out of a small, compact vent, but that still leaves you with a lack of cold air intake to cool the components. Many other laptop manufacturers, such as Dell, will have additional venting in their laptops, and although it may not look as aesthetically pleasing as Apple's choices, it's a case of function over form. Laptops from these manufacturers are often able to regulate their thermal temperature better than MacBooks. Although there are exceptions, and on average, those devices are bulkier and not as pretty. To attempt to solve the lack of venting and cold air intake, the solution that Apple's engineering team came up with was to use the laptop's hinge as a cooling vent. This was genius from a design point of view and is actually a great place to push hot air out, but that's only provided you put your laptop on a flat surface. If you use it on your bed or on your lap, you're very likely blocking air from getting out, which help prevent MacBooks from thermal throttling or overheating. Even if your MacBook is on a flat, unobstructed surface, like a tabletop, the physical size of the vent and as a result the volume of air that can be moved was still very small. And this still doesn't solve the problem of a cold air intake. The cooling system only has the already hot air to work with, which means that once your MacBook becomes hot, it's very difficult to cool it back down unless the heat being generated by the CPU or the GPU stops or is reduced. For example, your 3D render finishes. Arguably, the most infamous overheating and thermal throttling issues appeared when Apple decided to equip some of its MacBook Pro models with Intel's flagship 6-core Core i9 processors. Now don't get me wrong, when it comes to certain tasks like video editing or 3D animation, Intel's Core i9 CPUs are still quite good, despite Intel's flailing attempts at staying relevant in the CPU market. But if there's one thing they need in order to perform well, it's cooling, which the MacBooks really couldn't provide. The result was a configuration that would cause the processor to throttle every time the temperatures would become too high, and we aren't just talking about small amounts of throttling. We're talking about a Core i9 processor that oftentimes performed worse than the previous generation Core i7, something that just should not be happening with a configuration that costs that much. Apple's answer to why this happens was that a digital key in the laptop's firmware was lacking. This key was meant to deal with the thermal management system and prevent MacBooks overheating while also keeping the processor's clock speeds higher. They did put out a software update which was supposed to fix it shortly after the release of the Core i9 models, but it didn't do much. Users reported that the processors weren't throttling as much, with clock speeds not just being higher, but also remaining more consistent, with much less fluctuation. On the other hand, both synthetic benchmarks and software performance didn't improve, leaving users to wonder whether or not the software update changed anything, considering the MacBooks were still thermal throttling. Apple did find a way to deal with the Core i9 MacBook overheating issue. Well, two ways, one slightly more radical than the other. Firstly, they changed the thermal compound they used in their MacBooks. If you're not familiar with the purpose of thermal compound, it's to provide a connection between the CPU and a heatsink. The thermal compound acts as a bridge, allowing heat to transfer from the CPU into the heatsink, which is then dissipated into the air and exhausted out of the laptop. Various manufacturers are notorious for using the lowest quality possible thermal compounds. And in a compact chassis that runs a high-performance CPU, this is a recipe for disaster. The new compound was a lot more effective and had much better heat dissipation, which resulted in a massive impact on overall performance, positively of course. In my opinion, I can't really believe Apple had to make this change in the first place. I'd have thought they'd be using a premium thermal compound from the beginning, especially considering the premium price of the MacBooks. But I digress. Secondly, they undervolted the processors used in the MacBook Pro. By undervolting, they reduced the amount of energy the processor consumes, as well as the heat it dissipates, without having too much of an effect on performance. This was the other piece of the puzzle, and together with changing the thermal paste, this led to Apple being able to put an even more powerful 8-core Intel Core i9 processor inside the MacBook Pro and still have it perform relatively well with no significant thermal throttling under load. But according to a lot of users, this was mostly damage control because Apple was dealing with an issue they shouldn't have allowed to happen in the first place. I do have some sympathy for Apple because up until relatively recently, Intel chips were really the only option for most desktop and PC manufacturers, but the MacBook's design was still a limitation, and at some point, Intel's processors would be too demanding in terms of cooling to be a viable option, and the thermal throttling and overheating issues would rear their ugly head once again. That's where Apple's M1 Silicon comes in. Although it was a long time coming, Apple released their M1 chips last year. The M1 is an absolute powerhouse in terms of performance, and to add to that, Apple designed it with the chassis of their existing MacBooks in mind. It's important to note that the base of the MacBook chassis still does get very hot during intensive loads, and even the MacBook Pro, which features a fan, will thermal throttle slightly, but still nowhere near what the era of the Intel CPUs produced. What's even more impressive is that Apple was able to release the M1 MacBook Air as a completely passively cooled device without a single fan. Such a quantum leap in design and performance from the previous underpowered and overheating Intel MacBook Airs was mind-blowing for me personally, and I'm excited to see what the future holds for the MacBook lineup. And that's it. That's why MacBooks get so hot. Well, maybe not now that we have the M1 chips, which is good. And if you have any comments or questions, let me know down below. But apart from that, I will catch you in the next one.